Hi everyone, this is Mr. Go. Tonight we're going to take a look at how we use the Lewis dot diagrams to actually predict what their simple molecular geometries for these simple molecules would be. First thing that we need to understand is that there's this thing called VSEPR theory. Now, valence shell electron pair repulsion theory, or VSEPR theory, is just exactly what it's stating. They're talking about valence electrons, and they're talking about them in terms of pairs, and the fact that because these electrons are all negatively charged, they are all trying to get as far away from one another as possible. So when we draw the Lewis dot diagrams, note that we're drawing them on a two-dimensional plane. So when we fill this up on an imaginary element, we're talking about 8 electrons that are spread out around this atom, okay, as far away from one another as possible. Now take a look at the way I've drawn these. If we try to draw it in this way, understand that it seems like the furthest away that they can be is about 90 degrees. But these electrons are in three-dimensional space. So the furthest away that they can be can't be 90 degrees because this is actually much closer than they would be, okay, because this is 180 degrees away from each other. And we're talking about the distance away from this part right here and this part. So in order to maximize their distances, these electron pairs, in this case, or lone pairs, for this drawing right here, you have to think about them in a three-dimensional space. So let's try to go ahead and show you exactly what I mean. The way we're going to draw these are in terms of the wedge and dash method. So for example, let's say I have a central atom, like this, that has 4 things bonded around it. And let's say that those things that are bonded around it are hydrogens. The way we draw them is like this. So the hydrogen is over here, a hydrogen is right here. A hydrogen is coming out away from the screen towards you, right here. And then a hydrogen goes into the back, like this, like so. And again, this is called the wedge and dash method. The wedge, as drawn right here, is something to indicate that this hydrogen is coming out of the surface, or out of the page. The dash method, or dot method back here, is to indicate that the hydrogen is actually going into the page or into the surface of your actual drawing the way it is right here. So we use the wedge and dash method to show 3 dimensions in a 2-dimensional plane, and this is how we're going to draw these simple molecules. So now let's go ahead and take a look at how we would draw a simple molecule that's got 4 atoms, or 4 sort of electron pairs around it, maximizes the total number, the bond angles between each one of these guys right here. So the perfect example would be methane. So that's CH4. This is the simplest hydrocarbon that we have. And carbon, if we draw its Lewis dot diagram, has 1, 2, 3, 4 dots around it like this. And since there are 4 hydrogens and each hydrogen has 1 electron, what we can do is form bonds right here. Form bonds with another hydrogen here. Form another bond with this hydrogen. And another bond with this hydrogen right here. Now it looks like, again, that we have a 90-degree angle between these. But remember, because these are 3-dimensional molecules, we want to go ahead and show the wedge and dash drawing to indicate its 3 dimensions. So let's redraw this. Let's go ahead and start out with the carbon again. But instead of the carbon having 4 dots around it, kind of like at the north, south, and east and west side, what we'll do is we'll go ahead and draw a hydrogen up here, and a hydrogen over here, and 1 hydrogen coming out with the wedge, like so, and another hydrogen going into the back with these dashes, and like this. So this is the structure of methane. The shape actually is called a tetrahedral shape. Now it's called tetrahedral because tetra means 4. It's a 4-sided figure, and each side is actually a triangle. So there's a triangle between 1 here and here and here. a triangle between here, here, and here, a triangle between this one, and this one, and then a triangle between this one, and this one right there. So those are the 4 triangles. That's why it's called a tetrahedral in shape. So that's sort of a simple example of a simple explanation of VSEPR theory, simple example of a tetrahedral shape. Let's go ahead and take a look at some additional shapes in another video. All right, I'll talk to you guys soon.